This is going to be a quick video to go over the 7.1, 7.2 skills practice problems that we covered in class on Tuesday. I already went through the odd numbered problems in class, but you were asked to do the even numbered problems and many students had questions about these, so I just wanted to post a video to help clear them up. So down toward the bottom half of the page, we had some skills practice examples, and I'm going to run through the evens. In question 2, we are adding and subtracting, which means the rule we apply is combining like terms. So let's look for some like terms. 3x squared and x squared are like terms. So I'll just rewrite these, kind of couple them together in order. Instead of an x squared, I'm writing a 1x squared. That just helps me a little bit later. Then we've got a 4x and a minus x. So I'll have plus 4x minus 1x. And then finally we've got a minus 5 that doesn't have any like terms. So when I add these together, I'm only able to add the like terms to the like terms. So the 3x squared plus 1x squared can add together. That'll give me a 4x squared. We only add the number in the front. The bases and the exponents do not change. Next, I can add together the 4x and the negative 1x. That becomes positive 3x. Notice the base and the exponent didn't change, only the number in the front. Then we have a minus 5. That doesn't even have anything to add to, so here is our answer. For problem 4, this is all multiplication. So I'm going to rewrite all of the different pieces of this multiplication, but in an order that helps me see what I can multiply to what. So first I'm going to put the negative 3 times the 2, and then I'm going to write the j squared times the j, and then finally I'm going to follow it up with the k to the 4th times k to the 6th. So I've just grouped things by their bases. Let's start with simplifying the negative 3 times 2. Those multiply together to give us negative 6. Then our j's. It might be helpful to put a little 1 up as your exponent for that j that's missing an exponent. That will help you remember when you're multiplying these things together, you add their exponents, and since here we have a 2 and a 1, we will add them together to get j cubed. Now with the k's, very similar process. We're going to add our exponents together. 4 plus 6 gives us 10. So here is our answer for part 4. Moving on to 6. 6 is obviously a division problem. So we're going to start, I'm just going to rewrite my fraction here, and I'm going to color code the various factors involved. So I've got a 6 over 3, a p to the 4th over p squared, and an r squared over r cubed. So I'm doing this to color code what is allowed to be combined together. So let's take a look at the 6 divided by 3. Well, what's 6 divided by 3? That's just 2. Now let's look at the p's, the two parts that have a base of p. We would write p to the 4 minus 2. We take the top exponent minus the bottom exponent. That's our quotient rule. Then we would have an r to the 2 minus 3. Again, that's the quotient rule. Top exponent minus bottom exponent. So if we simplify this, we'll see that we have a p squared and an r to the negative 1. Well, that brings us to our final step. We have a negative exponent on this base. That means we need to move it to the bottom of the fraction. But there is no fraction, so we kind of have to make one. So this r to the first power moves down, but the 2p squared stays up top. And as a final note, you don't need the 1 exponent on the r, so we can go ahead and erase that, just so our answer looks nice and simplified. Number 8. Number 8 has a lot of steps, and I'm going to go through them one at a time. So first we're going to start with these exponents on the outside of the parentheses. They need to distribute in to each base on the inside. So I'll take this 3 exponent and I'll distribute it to the x cubed, to the y, and to the z squared. So here's the y, and here's the z squared. Then I'll take the 2 exponent, and I'll distribute it in to the 2, the x, and the y to the 5th. So that'll go 2 squared, x squared, y to the 5th squared. Many of these pieces can be simplified quite nicely. For instance, the 2 squared, that's really easy. That's 4. Y cubed and x squared, those don't need any simplification at all. We can just rewrite those. But then some of these are going to require us to apply a rule. For instance, x cubed cubed. That is a single base with multiple exponents. We have to use our power rule. So our power rule tells us to multiply our exponents together. X to the 9th. Similarly, with this z here, we've got another power rule. We'll multiply 2 times 3 and get z to the 6th. And finally, another power rule, y to the 5th squared, we multiply 5 times 2 and we get y to the 10th. Okay, now let's take a look, maybe even rewrite this in the right order. So I've got my number in the front, I've got my x to the 9th, I've got an x squared, I've got a y cubed, a y to the 10th, and a z to the 6th. So I've just rewritten this in the order of basically the alphabet to put my x's together, my y's together, and my z's together. These two x's are being multiplied. We can combine them by adding their exponents. So we end up with x to the 11. These two y's are being multiplied together, so we can combine them by adding their exponents. And then finally, this z is just kind of all by its lonesome, doesn't need to combine with anything, so we end up with this as our final answer. One more problem to do in this hopefully pretty short video. We have a few things going on in this problem. I'm going to rewrite it a little bigger because I'm having trouble seeing all the pieces on my screen. R to the negative 2, w cubed. Okay, so first things first, I see a w to the 0. That's just 1. We can just cross this off because this would be like saying, times 1 up here at the top, and we don't need that. So I'm just going to get rid of it. The next thing I see are a couple of negative exponents. So I'm going to circle the bases that have a negative exponent, and I'm going to flip those bases to the other side of my fraction. Notice that the 2 and the w cubed don't move, they stay right where they are, but the r squared moves up and the r cubed moves down. Well, now I'm looking at a fraction that has r's on top and r's on bottom. R's divided by r's. So basically, I'm dividing two things that have the same base. So I'm going to be using the quotient rule. The quotient rule says when we divide, we subtract our exponents. So this is really important. The r from our quotient rule is going to go up top. That's important. And then we subtract the top exponent minus the bottom exponent. So simplifying this a little bit, we get 2 times r to the negative 1 over w cubed, and we have that problem again. I have another negative exponent all of a sudden. So we're going to circle that base, which reminds us to move that base down to the bottom. So we get 2 over, don't forget your w cubed, that r to the negative 1 moves down, and it becomes r to the positive 1. But as a final reminder, you don't need to write the exponent of 1, so we can erase that. And our answer is actually relatively simple, but there were a lot of steps to get there. So I hope this video was helpful, and you get a chance to go back and take a look at your skills practice work from Tuesday. Have a good evening.